You rest in the dark, and the dark rests with you. Your body grows heavy in a way that feels kind, as if the earth remembers you and gently keeps you from drifting away. There is no effort in this holding. Gravity does not announce itself. It does not rush. It simply stays, patient and dependable, like a quiet companion who has always been there. You feel it now in the slow sinking of your muscles, in the steady contact between you and the surface beneath you. The planet carries your weight without complaint, just as it carries oceans, mountains, and cities. Gravity asks for nothing in return. It is the soft agreement between matter and space, a promise that things belong together. As your breathing slows, your thoughts begin to widen. Behind your closed eyes, the night no longer feels empty. Instead, it feels full in a gentle way, like a room dimly lit by a single lamp. You imagine the earth floating, round and calm, suspended in a vast darkness that is not hostile, only quiet. Space is not far away. It begins just beyond the thin air above you, and in some sense, it passes through you already. Gravity connects you to that space. It is the invisible thread between your body and the distant stars. The same pull that keeps you settled also guides the moon in its endless circling, and shapes the slow dance of planets around the sun. You are not separate from these motions. You participate in them without moving at all. The night listens as you do. There is no urgency in the universe at this hour. Stars burn, but they do not hurry. Galaxies turn so slowly that their motion feels more like a thought than an action. Gravity conducts this quiet orchestra, shaping paths and patterns over millions and billions of years, never raising its voice. You let yourself imagine gravity not as a force, but as a feeling. A gentle leaning. A preference that space has for matter, and matter has for space. Where there is mass, space bends toward it, like fabric yielding to a resting hand. This bending is subtle, almost tender, but it is enough to guide worlds. Your body, too, bends space in its own small way. The effect is tiny, immeasurable, but real. You are shaping the universe simply by being here. The thought does not need to be impressive. It only needs to be true. You are part of the conversation between matter and space, even as you lie still. The night grows quieter, and in that quiet, your sense of scale begins to soften. The universe no longer feels overwhelmingly large. Instead, it feels layered. There are distances beyond imagining, yes, but there are also closenesses that are easy to miss. Gravity reaches across space without crossing it. It touches without traveling. You consider how little resistance there is between you and the cosmos. Most of what you think of as solid is mostly empty space. Atoms are tiny centers surrounded by vast distances, more space than substance. Your body feels solid because of patterns and forces, not because it is filled. In a way, you are already mostly openness. This thought does not unsettle you. It relaxes you. If you are made of space as much as matter, then perhaps the universe feels familiar because it is. You are not enclosed within your skin so much as gently gathered by it. Gravity holds all of this together, quietly maintaining the shape of things. As the night deepens, your attention drifts outward. You imagine gravity extending far beyond the earth, thinning as it goes, but never fully disappearing. Its influence fades with distance, yet it reaches farther than intuition suggests. Even stars that seem isolated are aware of one another through this subtle pull. You sense that gravity is not only about falling, it is also about belonging. It tells matter where it fits, how it curves space around itself, how it responds to the presence of others. In this way, gravity is relational. It exists because things exist together. The darkness around you feels less like an absence and more like a presence. Space itself becomes something you can almost feel, pressing lightly, listening carefully. You imagine it as a vast, quiet field, attentive to every mass, every movement, every pause. Nothing happens without space noticing. Your thoughts slow further, becoming softer, rounder. You no longer chase them. You let them pass like clouds. Gravity continues its work whether you think about it or not. It keeps the earth whole, the atmosphere close, your body supported. It does not need your attention, but it welcomes it. There is comfort in knowing that such a fundamental part of the universe is so gentle. Gravity does not demand. It invites. It waits. Even its strongest expressions begin as simple curvature, as space responding naturally to what is placed within it. As you rest, a subtle curiosity begins to form, not sharp enough to disturb you, only present enough to linger. If gravity is everywhere, and space is mostly empty, what else might move through this openness? What might pass nearby without sound, without disturbance, without leaving a trace you could feel? The night does not answer. It only listens. And as you drift closer to sleep, that unanswered question settles beside you, quiet and patient, preparing you to follow gravity a little deeper, into the way it breathes through the universe itself. You remain still, and yet gravity continues to move. It does not rush past you or sweep you away. Instead, it flows slowly, like a breath the universe takes without thinking. Inhale, exhale. Hold, release. Gravity is not a push or a pull you can hear. It is a rhythm, steady and unbroken, shaping everything without needing attention. You imagine gravity as a tide, endlessly rising and falling, though never truly changing. Oceans respond to it visibly, lifting and lowering their edges twice each day. But the same tide moves through stone, through air, through you. You feel it in your weight, in the way your body settles more deeply as sleep approaches. Nothing resists this motion for long. Your breath begins to match the idea. Slow in, slow out. Gravity breathes with you, or perhaps you breathe with it. The distinction feels unimportant. What matters is the calm. The universe is not strained. It is not struggling to hold itself together. Gravity does its work with infinite patience. You picture planets forming long ago, not in moments of drama, but over quiet stretches of time. Dust drifts. Small pieces meet. Gravity encourages them to stay together, to gather, to grow. There is no command, no sudden force. Just a preference for closeness, repeated countless times, until a world appears. Stars, too, are shaped by this patient breath. Clouds of gas drift through space, thin and cold. Gravity begins to draw them inward, so gently that nothing seems to happen at first. But over time, the gathering becomes undeniable. The cloud warms. It tightens. At last, a star ignites, not as an explosion of anger, but as a steady awakening. You notice how often gravity works through waiting. It allows time to do most of the work. Where there is mass, it leans space inward, and over long durations, that leaning becomes structure. Galaxies take shape. Orbits settle into graceful repetition. Nothing needs to hurry when there is so much time. Your own body is part of this slow design. Every cell rests within Earth's gravitational field, responding without effort. You do not need to think about staying grounded. Gravity handles that for you. It keeps your blood moving the way it should. It gives your muscles something to press against, your bones something to support. As your awareness drifts outward again, you imagine gravity stretching across vast distances, becoming weaker but never disappearing entirely. Even between galaxies, where space feels almost empty, gravity still whispers. It links clusters together, guiding them in slow, deliberate motions that unfold over billions of years. You let yourself feel how different this is from how force is usually imagined. There is no shove. No impact. Gravity does not collide with things. It shapes the stage on which everything moves. Space curves gently in response to mass, and objects follow those curves as if they are the most natural paths available. This idea settles into you like a warm weight. Nothing is forced. Things move the way they do because space itself is shaped that way. Gravity is not something added onto the universe. It is part of how the universe arranges itself. You sense that gravity is deeply democratic. It treats all mass the same, whether it belongs to a grain of dust or a massive star. The difference lies not in how gravity behaves, but in how much space bends in response. More mass, deeper curve. Less mass, gentler slope. The night around you feels thicker with meaning now, though still calm. You imagine space as a soft landscape of hills and valleys, shaped by everything that exists. You rest in one of these valleys, held there without pressure. The earth creates a deep curve, and you naturally remain within it. As sleep draws closer, your thoughts begin to slow even further. You no longer try to picture the entire universe at once. Instead, you focus on a single idea: gravity does not need effort. It does not tire. It does not weaken with age. It is as present now as it was when the first atoms formed. This constancy feels comforting. In a universe full of change, gravity remains dependable. Stars burn out. Galaxies collide. But gravity continues, shaping whatever comes next with the same calm breath it has always used. Yet, somewhere in this steadiness, you sense the possibility of something more intense. If gravity's gentle pull can shape planets and stars over time, what happens when matter gathers so densely that space curves far more sharply? What happens when the valley becomes so deep that even light hesitates? The thought arrives softly, without fear. You are not imagining destruction or chaos. Only concentration. Gravity, patient as ever, simply becoming stronger where mass becomes tighter. Space bending more deeply, more completely, responding to an extreme presence. You feel curiosity stir, slow and quiet. Gravity, you realize, does not have a maximum personality. It does not change its nature. It only responds to what is there. If enough mass gathers into a small enough space, gravity's breath becomes deeper, slower, more profound. The night seems to lean in slightly, as if listening with you. You are still resting safely within Earth's gentle curve, untouched by extremes. But your mind drifts toward places where gravity gathers itself more tightly, where space folds inward beyond ordinary experience. You do not rush toward these places. You only acknowledge that they exist, patiently waiting to be understood. Gravity's slow breath continues everywhere, from the softest pull to the deepest bend. And as you hover on the edge of sleep, you sense that this deeper gravity has a story of its own, one that begins not with violence, but with quiet surrender, somewhere inside the heart of a dying star. You move gently toward a place where stars grow old. There is no urgency here, no sudden ending. A massive star reaches the final stages of its long burning life, having spent millions of years turning simple elements into heavier ones, layer by layer, like rings in a tree. It has shown faithfully, holding itself open against gravity's constant invitation to fall inward. Inside this star, balance has always mattered. Heat pushes outward, gravity leans inward, and for a long time, neither wins. The star exists in that quiet tension, suspended between expansion and collapse. You sense how patient this arrangement is, how long it can last, how stable it feels from the inside. But fuel is finite, even in the largest stars. Eventually, the reactions slow. The outward pressure weakens, just slightly at first, almost imperceptibly. Gravity notices immediately, though it does not hurry. It has been waiting since the star was born. The collapse begins not as a catastrophe, but as a release. Without enough heat to hold itself open, the star allows gravity to guide it inward. Matter moves closer to matter. Space curves more deeply. Layers fall through layers in a motion that feels less like destruction and more like letting go. You imagine this inward motion as a deep sigh. The star exhales its structure, surrendering the shape it once held. There may be a burst of light, a supernova visible across galaxies, but even that violence is brief compared to what follows. After the brightness fades, something quieter remains. At the center, matter compresses beyond familiar states. Atoms no longer keep their distance. Electrons are pressed into protons. Space itself yields, bending more sharply than before. Gravity does not change its nature. It simply responds to what is happening. This is how a black hole is born, not as a tear in reality, but as an extreme curve in space. Nothing magical is added. Nothing mysterious arrives from elsewhere. The same gravity you feel holding you to Earth is here too, only intensified by concentration. You sense how misleading the name can be. Black holes are not holes in the usual sense. They are regions where space curves so deeply that paths leading outward become impossibly steep. Light tries to climb away, but the slope is too great. It lingers, turns, and stays. The boundary of this region has a quiet name, the event horizon. It is not a surface you could touch. It is a threshold, defined by motion rather than matter. Crossing it feels ordinary to whatever falls in, yet from the outside, return is no longer possible. You rest with this idea, letting it feel less frightening and more inevitable. Black holes are not traps set by the universe. They are natural outcomes of gravity doing exactly what it always does when mass gathers tightly enough. Inside the event horizon, familiar descriptions fail. Space and time trade roles. Paths lead inward no matter which direction you face. Yet none of this feels hostile in your imagination. It feels precise, lawful, even elegant in its own way. You notice how often fear comes from imagining intention. But black holes have none. They do not hunt or consume. They wait. Matter that comes close enough simply follows the shape of space. There is no hunger, only geometry. As your thoughts slow, you realize how rare these objects actually are. They require stars many times more massive than the sun, lives spent building heavy elements, endings shaped by scale and time. Black holes are not scattered everywhere. They are carefully earned. Even the black hole at the center of a galaxy is not disruptive most of the time. Stars orbit it calmly, held at safe distances. Life, if it exists nearby, unfolds undisturbed. Gravity's extremes remain localized, contained by distance and balance. This understanding softens the darkness. Black holes become less like cosmic villains and more like quiet elders of the universe, formed late, carrying the memory of massive stars within them. You let your mind linger near one, not crossing any boundaries, only observing from afar. You imagine space curving inward like a deep well, smooth and symmetrical. Around it, the universe continues, stars shining, galaxies turning, unaware of the silent depth nearby. And then, slowly, another thought drifts in. If black holes form from massive stars, they must be large, you assume. Stellar mass black holes, millions or billions of times the mass of the sun, dominate your imagination. Enormous things leave enormous remnants. But gravity does not care about size, only density. It responds not to how big something is, but to how much mass is packed into how little space. The equation is simple, even if the consequences are not. You wonder what would happen if matter were compressed without the death of a star. Could gravity fold space tightly on much smaller scales? Could black holes exist that are not born from stellar endings at all? The universe has had many opportunities to experiment. In its earliest moments, energy was dense beyond description. Particles crowded together. Fluctuations rippled through space. Conditions existed that no longer occur. Your curiosity remains gentle, unforced. You are not searching for danger. You are noticing possibility. If gravity can shape darkness from the collapse of stars, perhaps it can do so in other, quieter ways. The night around you stays calm. Nothing here threatens you. The Earth continues its steady orbit. Your body remains held within a mild curve of space. Yet your thoughts drift toward a different scale, where gravity hides its power in places too small to notice. As you hover between waking and sleep, a final question settles softly beside you. Must every black hole announce itself with mass and magnitude, or could some be so small, so subtle, that they pass through the universe like whispers, unnoticed and unseen? You let the question from before settle gently, like dust floating down after being stirred. The idea of a black hole that is small feels contradictory at first. Your mind has learned to associate black holes with enormity, with stars collapsing and galaxies bending. Smallness does not seem to belong here. And yet, the universe often hides its most surprising truths in places that feel counterintuitive. You begin by loosening your sense of scale. Size, you remember, is not the same as mass. A thing can be tiny and still be heavy in ways that are difficult to imagine. You have felt this before, holding something small but unexpectedly dense in your hand. The surprise lingers longer than the weight itself. A tiny black hole, you learn to imagine, is not small because it lacks importance. It is small because gravity has done its work too well. So much mass has been pressed into so little space that the curve of space becomes extreme at a scale almost impossible to picture. The result is something compact beyond everyday understanding. You let yourself picture an object no larger than a grain of sand, yet heavier than a mountain. The image resists clarity, slipping through metaphor after metaphor. Your mind tries to assign shape, texture, size, but each attempt feels incomplete. This is all right. Some ideas are meant to be approached slowly. These hypothetical objects are often called tiny black holes, or sometimes primordial ones. The names themselves feel soft and tentative, as if scientists speak them carefully, aware of how strange they sound. These black holes are not known with certainty. They exist first as ideas, as possibilities written into equations and whispered between observations. You feel no disappointment in this uncertainty. Instead, it feels like openness. Science does not demand immediate answers. It allows room for ideas to rest before they are proven or released. Tiny black holes remain in that resting place, neither accepted nor dismissed. You imagine the universe as a place that once held far more density than it does now. In its earliest moments, everything was closer together. Energy and matter crowded into every corner of space. Under such conditions, gravity may have briefly found opportunities to fold space tightly, even on very small scales. If that happened, the resulting black holes would not need stars to form them. They would be leftovers from the universe's first breaths, formed not from collapse, but from abundance. Too much energy in too little space, settling into stable curves that persist even as everything else spreads out. These black holes would be ancient, older than stars, older than galaxies. They would drift quietly through the cosmos, interacting almost not at all. Their gravity would be intense close up, but fade quickly with distance. Unless you were extraordinarily near, you would never notice them. This thought feels strangely comforting. Something so extreme, yet so unobtrusive. A reminder that power does not always announce itself. That the universe can contain profound things that leave no mark on your daily experience. You imagine one passing through space, indifferent to stars, to planets, to you. It does not seek. It does not avoid. It simply follows the shape of space, moving as naturally as anything else. If it passes through matter, it barely interacts. Atoms are mostly empty, and the black hole is far smaller still. Your body remains relaxed as you consider this. There is no sense of threat here. Even if such an object were nearby, its presence would likely go unnoticed. The universe has learned how to balance extremes with vastness. You begin to sense why these tiny black holes are so difficult to find. They do not glow. They do not shout. They do not pull dramatically on their surroundings. They are defined more by absence than by effect. To notice them, one would have to listen for the quietest deviations, the faintest anomalies. This listening requires patience and humility. Scientists look not for spectacle, but for subtle mismatches between expectation and observation. A star that moves slightly differently than predicted. A burst of energy that arrives without an obvious source. Even then, explanations overlap, and certainty remains elusive. You appreciate this restraint. Not every idea must be confirmed immediately. Some are allowed to exist as gentle questions, shaping curiosity without demanding resolution. Tiny black holes live in that space of scientific imagination, grounded in mathematics, but still waiting for evidence. As your thoughts drift, you notice how this mirrors your own state. You are awake, yet close to sleep. Present, yet drifting. Existing between certainty and surrender. The universe seems to enjoy these in-between states. You return to the idea of density. How much can be held in how little space? You think of compression not as violence, but as closeness taken to an extreme. Gravity invites matter inward, and if conditions allow, matter accepts. In this way, a tiny black hole is not unnatural. It is simply gravity allowed to finish its sentence. No interruption. No opposing force strong enough to stop it. You feel a quiet respect for this simplicity. The laws that govern falling apples and orbiting moons also allow for objects that defy intuition. The difference is not the rules, but the scale at which they are applied. The night remains calm around you. Your body feels heavy, safe, untroubled. Whatever strange objects may exist in the universe, they have not disturbed this moment. The Earth has carried life for billions of years without interruption from such possibilities. You sense that the question is no longer could tiny black holes exist, but if they do, how would we ever know? This curiosity does not sharpen your thoughts. It softens them, like a candle flame seen through half-closed eyes. As sleep draws nearer, you allow the idea to remain unresolved. Tiny black holes may exist, or they may not. Either way, the universe has room for mystery without danger. It holds unanswered questions the way the night holds silence. And somewhere in that silence, you feel the pull of another thought approaching gently. If such tiny black holes were born long ago, in a younger universe, then their story must begin there, in the warmth and density of the very first moments of time. You drift backward in time without moving at all. The night around you fades, and in its place rises an image of the universe as it once was, young, compact, and glowing softly with heat. This is not a violent beginning in your imagination, but a warm one, like stepping into a room where everything is close together and quietly humming. In these earliest moments, space itself feels different. It is smaller, denser, filled everywhere with energy. There are no stars yet, no planets, no familiar shapes. Instead, there is motion without objects, potential without structure. Everything that will someday exist is present here in compressed form, waiting for time to stretch it out. You sense how crowded the universe feels at this stage. Particles are not isolated. They brush past one another constantly, exchanging energy, changing identity, appearing and disappearing. Gravity is already present, but it does not yet dominate. Other forces share the work of shaping behavior. The universe experiments, tries arrangements, releases them, and tries again. As expansion begins, it is not an explosion but a gentle loosening. Space stretches, slowly at first, then steadily. Energy thins out. Temperatures fall. The universe cools like a body settling into sleep, exhaling after a long-held breath. Yet this cooling is not perfectly smooth. Tiny variations ripple through the early universe. Some regions are slightly denser than others, slightly warmer, slightly more crowded. These differences are small, but they matter. Over time, gravity will amplify them, turning faint irregularities into galaxies and stars. You imagine this early universe like fabric being stretched. Most of it smooths evenly, but here and there, small knots form. Not because something goes wrong, but because the process is natural. Compression happens. Fluctuations occur. Gravity notices. In certain rare places, conditions may briefly allow matter and energy to crowd together enough for space to curve very sharply. No star is involved. No collapse of a massive object. Just an accidental gathering, a moment where density crosses a threshold. If gravity is patient everywhere else, here it acts decisively, not quickly, but completely. Space folds inward. A tiny black hole may form, small beyond comprehension, yet stable. Once created, it does not need fuel. It does not need light. It simply remains. These primordial black holes, if they exist, are fossils of the universe's earliest behavior. They carry information not in messages or signals, but in their mere presence. Each one would be a record of conditions that no longer exist, a remnant of a time when the universe was still learning how to be spacious. You find comfort in this idea. The universe does not discard its past entirely. It keeps traces, quiet souvenirs embedded in its structure. Some are visible, like background radiation whispering from every direction. Others, like tiny black holes, would be almost impossibly subtle. As the universe continues to expand and cool, these tiny black holes would be left behind. Space grows vast around them. Matter thins out. Stars eventually ignite, galaxies assemble, planets form. Meanwhile, these ancient objects drift, untouched by most of what unfolds. They do not grow easily. Their size makes them inefficient at gathering matter. Things pass by without falling in. Their gravity is intense only at distances so small that encounters are rare. Time moves on, and the black holes remain almost exactly as they were at birth. You imagine one traveling through the forming cosmos, passing between clouds of gas, between stars, between galaxies. It does not light up. It does not announce itself. It simply follows the curves of space shaped by everything else. This drifting is slow, measured in cosmic terms. Millions of years pass like moments. The universe becomes transparent. Light travels freely. Structures grow complex. Life, eventually, begins to wonder about its surroundings. All the while, these ancient objects may still be there, silent and unnoticed. Their existence would not disrupt the large patterns of the cosmos. They would not tear planets apart or destabilize stars. Their influence would be too localized, too small, to matter at human scales. You feel the gentleness of this scenario. Even the most extreme consequences of early universe physics are woven into a broader calm. Nothing here threatens the balance that allows galaxies and life to exist. Scientists, you sense, look back toward this era with careful attention. They search for indirect clues, subtle distortions in light, unexpected motions, missing mass that cannot be explained easily. Tiny black holes become one possible explanation among many, never demanded, never excluded. This uncertainty does not feel frustrating. It feels honest. The early universe is distant not only in time, but in accessibility. Much of what happened then cannot be replayed or observed directly. It must be inferred, slowly, through patterns that survive. You appreciate how science allows multiple stories to coexist until evidence chooses among them. Tiny black holes are one such story, consistent with known laws, but not yet confirmed. They remain possible without being required. As your thoughts soften further, you imagine the universe as a vast river of time. Near its source, currents are turbulent, crowded, full of eddies. As it flows onward, it widens, slows, and smooths. Tiny black holes, if they form, are like pebbles dropped near the beginning, carried along quietly as the river grows. Where are they now? Scattered everywhere, perhaps. Passing through galaxies, through dark space, through regions you will never see. Some may have evaporated over time, slowly losing mass through faint quantum effects. Others may still persist, unimaginably old. You do not feel small in the face of this timescale. Instead, you feel gently included. You are part of the later universe, shaped by those early conditions, even if you never encounter their most subtle remnants. The night returns to your awareness. Your body remains still, breathing slow and even. The Earth continues its calm rotation, untouched by ancient experiments playing out elsewhere. Yet your curiosity remains softly awake. If tiny black holes were born in the early universe and still wander today, then they may pass through regions of space without notice, including places you think of as solid and safe. The thought does not alarm you. It merely opens a door. If the universe is mostly empty, and these objects are small and quiet, then perhaps passage through matter is not dramatic at all. As you drift closer to sleep, one final question settles in, light as a whisper. If something so dense and ancient were to pass through the Earth itself, would anyone ever feel it, or would it slip through like a thought passing through the mind, leaving no trace behind? You return your attention gently to the Earth beneath you. It feels solid, dependable, unmoving. Your body trusts it completely. And yet, as your thoughts soften, that certainty begins to shift not into doubt, but into curiosity. You remember that solidity is a sensation, not a fact. It is how matter behaves at human scales, not how it is truly arranged. You begin to picture the Earth differently. Not as a dense, continuous object, but as a vast arrangement of space with islands of matter scattered throughout. Atoms, you recall, are mostly emptiness. Tiny nuclei sit at their centers, surrounded by wide regions where electrons drift like distant companions. If atoms were galaxies, their stars would be unimaginably far apart. Your own body shares this structure. You feel solid because forces hold these atoms in place relative to one another, not because they fill every available gap. There is space within you, enormous space, held in delicate balance by electric and quantum rules. The idea feels strange, but not threatening. It has always been true. Now you imagine a tiny black hole entering this picture. Not crashing, not colliding, simply passing through, following the curves of space as naturally as anything else. It does not push atoms aside. It does not scrape against them. Most of the time, it passes through the empty regions between them without interaction. Even when it passes near matter, the encounter is fleeting. Its size is far smaller than an atom. Its gravitational reach, while intense very close up, fades quickly with distance. The chance of it capturing a particle is extraordinarily small. Almost everything misses it entirely. You let this sink in slowly. A black hole passing through you would not feel like an impact. There would be no sensation, no heat, no sound. No pain. It would not tear cells apart or disrupt organs. The event would be quieter than a dream you do not remember. The same is true for the Earth itself. Beneath mountains and oceans, beneath cities and forests, the planet is also mostly space. A tiny black hole could pass straight through the Earth, entering one side and leaving the other, without disturbing its structure in any meaningful way. This thought might sound unsettling at first, but as you rest with it, it becomes oddly calming. Even one of the universe's most extreme objects becomes gentle when scale and probability are taken into account. The universe is not careless. It is spacious. You imagine such a passage taking place far below the surface, unnoticed. Rocks remain still. Water flows as it always has. Life continues uninterrupted. No alarm is raised because nothing has changed. If any energy were transferred at all, it would be vanishingly small. A slight vibration, far beneath detection. A whisper lost in the constant background of Earth's own movements. Earthquakes release more energy. Falling leaves disturb the air more noticeably. You feel your body grow heavier, more relaxed, as fear dissolves into understanding. The mind often fills unknown spaces with danger. But knowledge gently replaces the danger with proportion. Tiny black holes, if they exist, are not cosmic bullets or silent threats. They are passengers in a universe that is mostly empty, moving through it without urgency or intent. They are governed by the same laws that keep you safely grounded right now. You breathe slowly, imagining the Earth floating as it always has, resilient and calm. For billions of years, it has endured impacts from asteroids, eruptions from within, changes in climate and chemistry. Through it all, life has adapted, persisted, and flourished. If tiny black holes were common and dangerous, the Earth would show signs of their passage. The moon would bear scars. The planets would wobble. The evidence would be undeniable. Yet the solar system remains stable, its motions predictable and gentle. You rest in that stability. The universe is not hiding threats in silence. Its dangers, when they exist, are usually loud, bright, and rare. Tiny black holes, by contrast, would be quiet to the point of invisibility. This quiet does not mean insignificance. It means subtlety. The universe operates on many levels at once, from the dramatic to the nearly imperceptible. Not everything meaningful announces itself. You begin to see how this idea connects back to your own inner experience. Thoughts pass through your mind constantly. Some are loud and disruptive. Others drift through so gently that you barely notice them. Both are real, but only some leave a mark. A tiny black hole passing through Earth would be like one of those gentle thoughts. Present for a moment. Gone the next. Leaving no trace behind. As sleep draws nearer, your body feels increasingly supported. Gravity holds you as reliably as ever. Nothing about this moment is fragile. The planet beneath you has endured far more dramatic events than anything so subtle. You let yourself trust and scale, in probability, in the vastness that smooths extremes into calm. The universe has room for strange possibilities without turning them into threats. Your curiosity remains, but it no longer carries tension. Instead, it feels like quiet wonder. How many things pass through space, through matter, through you, without ever being noticed? The night remains still. Your breathing slows further. Somewhere far away, or perhaps nowhere at all, a tiny black hole may drift through the universe, indifferent and unseen. And as you hover on the edge of sleep, another question begins to form, just barely. If such passages are so gentle and rare, how could anyone ever hope to notice them at all, except by listening for the faintest footprints left in silence? You imagine a different kind of listening now. Not the kind that strains or demands, but the kind that waits. Somewhere in quiet rooms and deep underground spaces, people sit with machines designed not to shout, but to notice. They are listening for things that do not announce themselves, for events that leave almost nothing behind. This listening feels familiar to you, because it resembles the state you are in now. Relaxed. Attentive. Open. When you stop trying to force sleep, it often arrives more easily. In the same way, scientists searching for subtle phenomena learn to let the universe speak in its own time. Tiny black holes, if they pass through Earth, would not ring alarms or tear matter apart. Their footprints would be faint, so faint that most noise would drown them out. To hear such quiet events, one must first learn how to quiet everything else. You picture detectors buried deep beneath the ground, shielded from cosmic rays and surface vibrations. Rock and soil act like blankets, muting the constant chatter of the surface world. Here, instruments listen for minuscule changes, tiny jolts, slight shifts, patterns that do not belong to everyday motion. Some detectors watch for vibrations, subtle ripples moving through solid earth. Others watch for flashes of light in dark chambers filled with clear liquid. Still others track the motion of atoms with exquisite precision. Each approach is different, yet all share the same philosophy: patience over force. You sense how careful this work must be. A passing truck, a distant earthquake, even thermal noise from warm equipment can mimic or obscure the signal being sought. The challenge is not only to detect something rare, but to rule out everything else first. This is where silence becomes valuable. When nothing happens, it is not a failure. It is information. Each quiet hour narrows the range of what is possible. Each non-detection teaches scientists how often certain events do not occur. You rest with this idea. Absence is not emptiness. It is shape. It is boundary. It tells you where something is not, which slowly reveals where it could be. Searching for tiny black holes becomes a lesson in humility. You cannot demand proof on a schedule. You cannot design an experiment guaranteed to succeed. You can only create conditions where noticing becomes possible, and then wait. You imagine scientists checking data late at night, screens glowing softly in dark rooms. Patterns scroll by, most of them ordinary. Occasionally something strange appears, a signal that does not quite fit expectations. Excitement stirs, but caution follows closely behind. Extraordinary claims require extraordinary care. Every anomaly must be questioned, tested, compared. Could it be noise? Could it be an unfamiliar but ordinary process? Only after exhausting simpler explanations does the mind allow itself to wander towards stranger ones. This restraint feels gentle, almost meditative. It mirrors the way you learn to observe your own thoughts without immediately believing them. A strange idea arises. You notice it. You let it pass. Only some thoughts are worth holding on to. You realize that science advances not only through discovery, but through disciplined doubt. By not rushing to conclusions, it preserves trust. By listening longer, it learns more. Tiny black holes, in this sense, are teachers even if they are never found. They push experiments to become more sensitive, models more precise, understanding more complete. They refine questions, even if they never answer them directly. You feel comfort in this process. The universe does not owe immediate clarity. It invites curiosity without promising resolution. This is not cruelty. It is depth. As your breathing slows, you imagine the Earth itself as part of this listening network. The planet constantly vibrates, hums, shifts, and settles. Most of this motion comes from familiar sources: tectonic plates, oceans, winds, human activity. Against this background, a tiny black hole's passage would be like a single grain of sand falling into a storm. And yet, with enough patience, even grains of sand leave patterns. Over long timescales, statistics emerge. Patterns of absence accumulate. Limits tighten. The universe reveals what it allows and what it does not. You sense that listening is an act of trust. It assumes that reality is consistent, that patterns exist even when they are hidden, that patience will eventually be rewarded with understanding, if not of the thing itself, then of its boundaries. This kind of trust feels deeply aligned with sleep. You do not force yourself to rest. You create the conditions, dim the lights, quiet the mind, and allow the body to do what it already knows how to do. Science, at its calmest, works the same way. It builds quiet spaces where subtle truths can surface. You imagine a future where detectors grow even more sensitive, where noise is reduced further, where listening becomes finer still. Perhaps one day, a signal will appear that resists all ordinary explanations. Perhaps it will hint at something ancient and tiny passing through. Or perhaps it will not. Perhaps the silence will continue, teaching a different lesson, that such objects are rarer than imagined, or smaller, or non-existent. Either outcome deepens understanding. You feel no disappointment in this uncertainty. The universe remains generous with wonder, even when it withholds answers. Not knowing becomes part of the experience, not a failure of it. The night around you feels especially quiet now. Your thoughts drift more slowly, like leaves settling on still water. You are no longer actively imagining detectors or data. You are simply aware of listening itself. Listening without tension. Listening without expectation. Listening is a way of being present. In this stillness, you sense how fear has no place. What is feared is usually loud in the mind. But what is quiet rarely threatens. Tiny black holes, if they exist, belong to the quiet category of the universe, subtle, rare, and deeply indifferent to human concerns. You rest in that indifference, finding it oddly comforting. The universe does not single you out. It does not target or watch. It simply unfolds according to patterns that are older and larger than fear. As sleep approaches, one last reflection drifts through you. Whether or not tiny black holes are ever found, the act of listening for them has already revealed something important. The Earth remains unharmed, stable, and calm despite billions of years of cosmic history. And with that realization, a gentle reassurance begins to form, preparing you for the next quiet truth that even in a universe capable of extremes, safety is often written into the vastness itself. You return again to the feeling of safety beneath you, the steady presence of the earth, the way it supports your body without asking for attention. Nothing about this moment feels fragile. Nothing feels temporary. And as your thoughts continue to soften, you begin to understand why this sense of safety is not an illusion, but a reflection of how the universe is arranged. Fear often arises when imagination outruns proportion. The mind pictures extremes without context, danger without scale. Black holes, especially, have a way of attracting dramatic images. They are described as devourers, destroyers, cosmic traps. But these descriptions belong to stories, not to the quiet mathematics that governs reality. You remind yourself that the Earth has existed for over 4 billion years. In that immense span of time, it has orbited the Sun billions of times, passed through changing regions of the galaxy, endured bombardments, freezes, and fiery upheavals. Life has survived all of it. If tiny black holes posed a real threat, the evidence would already be written into the planet's history. The absence of such evidence is not mysterious. It is expected. Tiny black holes, even if they exist, interact with matter extraordinarily weakly. Their defining feature, extreme density, is confined to an unimaginably small region of space. Outside that region, their influence fades rapidly. You picture gravity again as a curve in space. For Earth, that curve is wide and gentle. For a tiny black hole, it is steep but narrow. Unless something passes extremely close, closer than atoms usually approach, there is almost no effect at all. This is why the Earth remains unharmed. Most matter simply misses. Atoms are spread far apart relative to their size. The chance of a tiny black hole encountering a nucleus directly is so small that even over billions of years, such events would be negligible. Even in the rare case of an interaction, the effect would be microscopic. A single particle might be captured. A minuscule amount of energy transferred. Nothing that could cascade or grow. Nothing that could accumulate into damage. You feel your breathing deepen as this understanding settles. Catastrophe requires feedback, amplification, runaway processes. Tiny black holes provide none of these. They pass through matter like a needle through fog, and even that image exaggerates their impact. The Earth, meanwhile, is anything but delicate. It absorbs far more energetic events every day. Cosmic rays strike the atmosphere constantly, particles from distant explosions colliding with molecules above your head. The sun bathes the planet in radiation. The core of the Earth churns with immense heat and pressure. Against this backdrop, the passage of a tiny black hole would be quieter than silence. It would not register against the ongoing symphony of natural processes. You begin to see how fear dissolves when scale is restored. What feels threatening in isolation becomes harmless in context. The universe contains extremes, yes, but it also contains vast buffers of distance, probability, and time. Safety, you realize, is not guaranteed by the absence of strange things. It is guaranteed by how rarely those things intersect with you in meaningful ways. the same principle protects you from most of the universe. Stars explode, but they are far away. Galaxies collide, but on timescales that dwarf civilizations. Even large black holes sit quietly at the centers of galaxies, their influence controlled by distance and orbit. You rest with the idea that danger in the universe is usually dramatic and obvious when it exists. Asteroids leave craters. Supernovae leave remnants. Events that matter leave traces. Tiny black holes leave none. This does not make the universe boring. It makes it balanced. It allows complexity to arise without being constantly erased. It allows life to take hold and persist. You think of how many opportunities there have been for catastrophe, and how few have come close. Earth's long history is not a miracle of constant luck, but a reflection of stable laws and generous scales. The universe is not designed to threaten you. It is designed to behave consistently. Fear often comes from imagining intention where there is none. Black holes do not seek. Gravity does not choose. Tiny black holes, if they exist, do not wander with purpose. They simply follow paths shaped by space, indifferent to what they pass. This indifference feels strangely comforting. You are not being watched or targeted. You are simply part of a vast system where most interactions are rare, gentle, or non-existent. You feel your body sink further into rest. Muscles loosen. Thoughts slow. The reassurance does not come from denial, but from clarity. Understanding has replaced alarm. You realize now why scientists speak calmly about these ideas. Not because they underestimate danger, but because they measure it carefully. Their confidence is built on numbers, probabilities, and evidence gathered over long periods of time. Earth remains unharmed because it is large compared to tiny black holes, and because tiny black holes are small compared to everything that matters at planetary scales. Scale protects you. Distance protects you. Probability protects you. Time protects you. You let this protection feel real. You do not need to stay alert. Nothing is approaching. Nothing is hidden beneath your feet. The ground supports you as it always has. The universe allows mystery without menace. It allows unanswered questions without immediate consequences. As sleep draws nearer, your curiosity shifts again, not toward danger, but toward emotion. You notice how easily the mind turns the unknown into fear, and how gently knowledge turns it back into wonder. Perhaps the most important thing learned here is not about black holes at all, but about perspective. About how understanding reshapes feeling. You rest in that reshaping now. Fear loosens its grip. Wonder takes its place, softer and warmer. And as your thoughts begin to drift toward dreams, one final reflection rises quietly: if knowledge can turn fear into calm, then perhaps black holes are not symbols of danger at all, but invitations to learn how vastness can hold even the darkest ideas without harm. You notice how quietly your thoughts have changed. Earlier, darkness invited tension, and mystery felt sharp at the edges. Now, as you rest within a deeper understanding, the same darkness feels spacious rather than threatening. Nothing in the universe has changed. Only your perspective has shifted. Fear often begins where imagination outruns understanding. The mind dislikes blank spaces. When it cannot see what lies ahead, it fills the darkness with motion, intention, danger. This is not a flaw. It is a protective habit, shaped by survival on small scales. But the universe is not small, and its mysteries are rarely personal. You sense how easily black holes have carried symbolic weight. They are spoken of as devourers, as mouths in space, as endings without return. These metaphors cling because they resonate emotionally, not because they are accurate. They give shape to uncertainty, but they also distort it. Science, you realize, does not remove mystery. It reshapes it. It replaces sharp fear with soft curiosity. It does not say, "There is nothing to be afraid of," but instead asks, "What is actually happening here?" When you look again at black holes through this lens, they feel different. They are no longer looming threats hidden in the dark. They are specific outcomes of gravity and mass, governed by rules that apply everywhere. Their behavior is constrained, predictable, and limited by scale. This shift from fear to wonder is subtle, but profound. Fear narrows attention. It locks the mind into vigilance. Wonder, by contrast, opens attention. It invites exploration without urgency. You feel this opening now. The universe no longer feels like a place full of traps. It feels like a place full of processes, slow, lawful, indifferent to drama. Black holes become one expression among many, not an exception waiting to cause harm. You reflect on how often fear comes from imagining yourself at the center of events. But the universe does not revolve around you. It does not organize itself to surprise or threaten. Most of what happens occurs far away, over long timescales, at scales too large or too small to intersect with your life at all. This realization does not diminish you. It relieves you. You are not responsible for monitoring the cosmos. You are free to rest within it. Wonder carries humility with it. It allows you to say, "I do not know," without discomfort. It replaces control with curiosity. You do not need to master the universe to feel safe within it. You sense how this attitude mirrors sleep itself. You cannot force sleep by effort. You allow it by releasing control. In the same way, you allow wonder by releasing the need to guard against every unknown. Black holes, once framed as ultimate dangers, now appear as teachers of scale. They show how extreme conditions can exist without dominating everything around them. They remind you that intensity can be localized, contained, and rare. Even the darkest regions of space are surrounded by calm. Even the most extreme curvature of space exists within a universe that remains broadly stable and gentle. You begin to see how fear collapses complexity into a single emotion, while wonder expands it into many questions. Fear asks, "What if something goes wrong?" Wonder asks, "How does this fit into everything else?" That difference matters. It shapes how you experience not just science, but uncertainty itself. You think of how many things once feared are now understood. Eclipses were once omens. Comets were once warnings. The night sky itself was once a source of dread. Understanding did not make these things smaller. It made them more beautiful. Black holes follow the same path. As understanding grows, fear recedes, and what remains is awe, quiet, respectful, and steady. You let that awe settle into your body. It feels warm rather than electric. It does not demand attention. It accompanies rest easily. The universe, you realize, is not obligated to be comforting, but often it is, simply by being consistent. Laws do not change abruptly. Patterns repeat. Extremes are balanced by vastness. Fear thrives on unpredictability. Wonder thrives on pattern. You feel grateful for the patience of science, for its refusal to exaggerate. Its calm voice has gently guided you from alarm to appreciation, from imagining danger to understanding structure. This does not mean all fear disappears. Some uncertainty always remains, but it no longer dominates. It becomes one note in a larger harmony. As your breathing slows further, you notice how wonder feels compatible with sleep in a way fear never is. Fear sharpens. Wonder softens. Fear wakes the body. Wonder allows it to rest. You are not falling asleep because mysteries have vanished. You are falling asleep because mysteries have found their proper place, vast, distant, and not demanding immediate action. You sense how this lesson extends beyond black holes. Many things in life appear frightening until scale and context are restored. When you step back, patterns emerge. When you slow down, intensity fades. The universe teaches this lesson repeatedly, in orbits, in cycles, in long durations that smooth sharp edges into curves. Black holes, paradoxically, help you trust the universe more, not less. They demonstrate that even extremes follow rules. Even darkness has structure. You feel yourself drifting now, held by gravity, by understanding, by the quiet confidence that comes from seeing the difference between fear and wonder. Fear isolates you inside imagined threats. Wonder connects you to the larger story. As your thoughts grow slower and more dreamlike, you sense the final transition approaching. From analysis to acceptance. From curiosity to rest. The universe does not require you to stay awake and watch it. It continues whether you observe or not. And as you sink gently towards sleep, one final realization settles in softly. If the universe can hold black holes without chaos, then it can surely hold your small uncertainties too, quietly, patiently, and without harm. You feel your awareness settle gently back into your body. Limbs rest, spine supported by the earth beneath you, heart beating with the quiet rhythm of gravity. Every breath carries a subtle reassurance, you are held, and everything outside continues its journey without interruption. The night is calm, and so are you. Looking outward through closed eyes, the universe feels like a vast, transparent ocean. Light travels uninterrupted, planets orbit faithfully, and galaxies spin in silent harmony. Space is neither hostile nor chaotic, it is patient, methodical, and immense. You are a quiet observer, part of its flow, not threatened by it. Even tiny black holes, born long ago and possibly drifting silently through the cosmos, are not a cause for alarm. They pass like whispers of thought, small and subtle, interacting with matter only in the rarest, most improbable instances. You imagine one weaving through stars and planets, leaving no mark, slipping through space as effortlessly as your dreams slip through the night. You notice how extraordinary it is that something so dense can exist without tearing the universe apart. This contrast deepens your wonder. The cosmos contains extremes you cannot fully grasp, yet life, including your own, continues undisturbed. Stability emerges not in spite of extremes, but because of scale, distance, and the quiet laws that govern everything. Your mind drifts further, embracing the notion of patience that permeates the cosmos. Gravity moves steadily, stars evolve over millions of years, and galaxies dance slowly across space. Even change is measured, deliberate. You recognize that your own pace, slow, rhythmic, unhurried, mirrors the movement of the universe at large. You imagine listening again, this time not for signals or tremors, but for the quiet harmony of existence. Every particle, every star, every black hole participates in an enormous symphony. Some notes are faint, some are bold, yet the music flows continuously, uninterrupted by your awareness. The earth beneath you participates in this music, orbiting, rotating, breathing through tides, weather, and life itself. Contemplating scale, you see that your concerns, fears, uncertainties, imaginings are small in context, but not insignificant. They are your own subtle movements in the symphony, acknowledged and contained. The universe does not need your permission to operate, yet your presence adds quiet meaning to its vastness. You drift further into reflection, considering the balance between mystery and understanding. The cosmos is full of both. Questions linger about tiny black holes, about dark matter, about forces beyond perception, but they are invitations, not threats. You are free to hold them lightly, letting curiosity coexist with calm. Sleep begins to brush against the edges of your consciousness. Thoughts slow, images become less distinct, awareness of time softens. You are neither chasing answers nor resisting unknowns. You exist in the space between questions and comprehension, where rest can arrive effortlessly. In this space, even the most extreme objects, the black holes, the densest stars, the earliest remnants of the universe appear gentle. They follow patterns. They move through the cosmos without urgency or ill intent. Your imagination allows them to drift past, distant yet present, like echoes of a silent orchestra, never interfering with the tranquility beneath your body. You notice the rhythm of your own breathing, in harmony with these larger cycles. Each inhale stretches like a cosmic wave, each exhale settles like a star collapsing gently into its orbit. Time becomes elastic. Moments expand, contract, and fold softly into one another. You do not need to follow them, only to exist within their flow. The earth continues its quiet journey, spinning, orbiting, warming and cooling. Rivers flow, oceans shift, mountains endure. Life unfolds according to processes that are ancient and resilient. You are part of this story, a brief note in an ongoing melody that began long before your awareness and will continue long after it. You allow gratitude to surface quietly. For your body, for your mind, for the calm that comes with understanding scale. For the universe, which is generous enough to harbor extremes and mysteries while also supporting life and consciousness. Gratitude does not excite or agitate, it settles softly, like dust on still water. Thoughts of tiny black holes fade gently, leaving only an impression of possibility. You understand now that not all unknowns are dangerous. Some exist quietly, without notice, reminding you of the depth and breadth of reality. They pass, unobserved, but not absent, subtle, but not threatening. You feel the boundary between yourself and the universe soften. You are heavy and grounded, yet simultaneously part of something vast and interconnected. The laws of physics that guide stars also hold you in place. The silence you hear is not empty, it is the music of balance, the sound of existence flowing unobstructed. Sleep deepens. Awareness of your body becomes rhythmic, synchronized with breath and heartbeat. Thoughts become gentle waves rather than crashing tides. The universe no longer seems distant or intimidating. Its patterns, its mysteries, its extremes all are folded into a larger, coherent whole, in which you rest safely. And as your eyelids finally grow heavy, a final thought drifts through the quiet. In a universe so immense, with black holes passing silently and stars glowing steadily, you too can drift through life and sleep with calm assurance, held within a cosmos that is vast, patient, and quietly protective. The night embraces you. The earth supports you. And the universe, in all its hidden complexity, flows on, leaving you softly suspended in the gentle certainty of being.